Welcome to the lecture Introduction to Digital Archaeology. An overview of the contextual topic of digital archaeology. Here we see an overview of the topics we want to discuss in this lecture. This should help us later to find the individual topics more quickly. Let's start with the following question. What do we actually mean by digital archaeology in general? Digital archaeology is a multifaceted field that encompasses the application of digital technologies to archaeological research, heritage management, and public engagement. It involves the use of computational methods and digital tools to record, analyze, interpret, and present archaeological data. This includes everything from the initial data capture in the field to the final dissemination of research findings. Digital archaeology can be understood through several key aspects. First, digital data acquisition, employing technologies like laser scanning, photogrammetry, and geophysical surveys to create digital representations of archaeological sites and artifacts. Second, data management and analysis, utilizing databases, geographic information systems, GIS, and statistical software to organize, analyze, and interpret archaeological data. Third, virtual reconstruction and visualization, creating 3D models and virtual environments to reconstruct past landscapes, buildings, and artifacts, allowing for immersive exploration and understanding. Fourth, digital heritage management, using digital tools to document, preserve, and monitor archaeological sites and cultural heritage, ensuring their long-term protection. And fifth, public engagement and education, employing digital media such as websites, virtual museums, and interactive exhibits to engage the public with archaeology and promote cultural heritage awareness. Citizen science and public engagement are becoming increasingly important in archaeological work. Here, for example, we see the results of the Reborn project, which are accessible to the public and thus underline the importance of archaeological work and make the value of cultural heritage even more tangible. The roots of digital archaeology can be traced back to the early days of computing, when archaeologists began to explore the use of statistical methods and computer databases for analyzing archaeological data. However, it was the advent of personal computers and the development of GIS software that truly revolutionized the field. The following are certainly important milestones in the development of digital archaeology. In the 1960s to 1970s, statistical methods and computer databases were used for data analysis at an early stage. The 1980s to 1990s were characterized by the emergence of GIS and its application to the spatial analysis of archaeological landscapes. There was also a development of computer-aided design for the reconstruction of architectural remains. The spread of digital imaging technologies such as laser scanning and photogrammetry, which enable the creation of high-resolution three-dimensional models, was a milestone from the 2000s onwards, with the increasing use of the Internet for data exchange and public involvement. From the 2010s until today, there has been a strong development of advanced analysis techniques such as agent-based modeling and network analysis, integration of virtual reality and augmented reality technologies for immersive archaeological experiences. Modern archaeology is experiencing a growing emphasis on open data and reproducible research. Digital archaeology relies on a wide range of technologies and tools, each contributing to different aspects of the archaeological process. We can say that the following aspects make up modern archaeology. Geophysical surveying. Techniques like ground-penetrating radar and magnetometry are used to detect subsurface features without excavation. Laser scanning creates highly accurate 3D models of landscapes and buildings by measuring the distance to a surface using laser light. Photogrammetry generates 3D models from a series of overlapping photographs. Geographic information systems, software used to manage analyze, and visualize spatial data, allowing archaeologists to study the distribution of artifacts and sites across landscapes. 3D modeling software, programs like Blender, Maya, and 3ds Max are used to create detailed 3D models of artifacts, buildings, and landscapes. Virtual reality and augmented reality, technologies that allow users to experience immersive virtual environments or overlay digital information onto the real world. Databases, used to store and manage large amounts of archaeological data, including artifact descriptions, excavation records, and survey data. Statistical software, programs like R and SPSS are used to analyze quantitative data and identify patterns and trends. Network analysis, a method for studying relationships between individuals, groups, or objects, often used to analyze social networks in the past. And finally, agent-based modeling, a computational technique that simulates the behavior of individuals or agents within a system, allowing archaeologists to explore complex social and environmental processes. Digital archaeology offers numerous opportunities for advancing archaeological research, heritage management, and public engagement. However, it also presents certain risks and challenges that need to be addressed. On the positive side, we can say digital technologies allow for more accurate and comprehensive data recording, leading to more robust and reliable analyses. 3D models and virtual environments can help archaeologists visualize and interpret complex archaeological data, leading to new insights and understandings. Geophysical surveys and remote sensing techniques allow archaeologists to investigate sites without excavation, minimizing damage to fragile archaeological remains. Digital tools can be used to monitor and manage archaeological sites, helping to protect them from damage and destruction. Digital media can be used to engage the public with archaeology, promoting cultural heritage awareness and fostering a sense of stewardship. And finally, digital data can be easily stored and shared, ensuring its long-term preservation and accessibility for future researchers. On the other hand, we must also be aware of the risks. Digital data is vulnerable to loss or corruption due to hardware failure, software errors, or cyber attacks. Digital technologies are constantly evolving, and data formats and software programs can become obsolete over time. Unequal access to digital technologies and skills can create a digital divide, limiting participation in digital archaeology. The use of digital technologies in archaeology raises ethical concerns related to data privacy, intellectual property, and the representation of cultural heritage. There is also a risk of becoming overly reliant on technology, neglecting traditional archaeological methods and critical thinking. And finally, digital data can be misinterpreted if not properly analyzed and contextualized. Now let's go one step deeper and ask ourselves what archaeological data types we are actually dealing with. Here we see an overview of the main data types encountered in archaeological research. Understanding these data types is fundamental for effective data management, analysis, and dissemination within the field of archaeology. Spatial data forms the foundation of archaeological analysis, providing the geographic context for all other data types. It allows archaeologists to understand the distribution of artifacts, features, and sites across landscapes, and to reconstruct past human activities in their spatial dimensions. Examples are coordinates and site plans. Descriptive data provides information about the characteristics and attributes of archaeological finds, features, and contexts. This data is essential for classifying, comparing, and interpreting archaeological materials. Examples are typologies, context sheets, and stratigraphic data. Media, including photographs, 3D scans, and videos, provide visual and interactive documentation of archaeological sites, artifacts, and excavations. Metadata is data about data. It provides essential information about the provenance, authorship, standards, and other characteristics of archaeological data. By understanding and effectively managing these four primary data types, archaeologists can ensure the integrity, accessibility, and long-term preservation of the archaeological record, facilitating meaningful research and interpretation for generations to come. Here I would like to show the Pleiades project as an example. It is a central digital tool of the archaeological geodata infrastructure. It provides structured, citable location information and enables geographical data to be semantically linked with other archaeological data types. Thanks to its openness and interoperability, it promotes transparent, comprehensible and networked research in the field of digital archaeology. Why should it be important to think about standards in digital archaeology? It is clear that standards are of crucial importance in digital archaeology. They ensure interoperability between datasets and platforms, facilitate the reuse of archaeological data for different research purposes, and guarantee the long-term preservation of valuable archaeological information. Interoperability, the ability of different information systems, devices, or applications to connect and communicate in a coordinated manner, is paramount in digital archaeology. Archaeological projects often involve diverse teams, institutions, and data types, ranging from excavation records and artifact catalogs to geophysical surveys and 3D models. Standards provide a common language and framework for describing and organizing archaeological data. They define consistent terminologies, data structures, and metadata schemas, enabling different systems to understand and exchange information seamlessly. This interoperability is crucial for, first, combining data from multiple sources to create a comprehensive picture of a site or region. Second, facilitating collaboration among researchers by enabling them to share and analyze data using different tools and platforms. And third, transferring data between different systems or formats without loss of information. Without common standards, integrating these disparate datasets becomes a complex and error-prone task. The archaeological project Çatalhöyük is a pioneering example in the use of digital documentation techniques and plays a key role in the context of long-term digital archiving. Through the systematic recording and publication of large volumes of field data, finds, contextual information, and interpretations, the project recognized early on the importance of making this information sustainably stored, interoperable, and openly accessible. By collaborating with digital repositories such as OpenContext and the Archaeological Recording Kit, the project ensured that its data were made machine-readable, future-proof, and assigned persistent identifiers, all of which are essential criteria for digital preservation. As a result, it became a model project for archaeological data management, promoting transparency in research and enabling long-term reusability by scholars, the public, and interdisciplinary initiatives. Several standards are widely used in digital archaeology to promote interoperability, reuse, and preservation. Here we see three prominent examples. The CIDOC conceptual reference model is an ontology, a formal representation of knowledge designed for cultural heritage information. It provides a common framework for describing and integrating data from diverse sources, such as museums, archives, and archaeological sites. It defines a set of classes and properties that can be used to model archaeological entities, events, and relationships. By mapping data into it, researchers can create a semantically rich and interoperable knowledge base. Dublin Core is a simple metadata standard consisting of 15 elements such as title, creator, subject, and date. It is widely used for describing a variety of digital resources, including archaeological datasets. Dublin Core provides a basic level of metadata that can be easily implemented and understood, making it a valuable tool for data discovery and reuse. The Archaeology Data Service in the UK provides a comprehensive set of guides and best practices for digital archiving in archaeology. These guides cover a wide range of topics, including data management planning, metadata creation, file format selection, and long-term preservation strategies. The guides are widely recognized as a leading resource for digital archaeologists and are used by institutions around the world. Now let's talk about the FAIR principles for scientific data management, which were published in 2016. The FAIR data principles were developed to improve the findability, accessibility, interoperability, and reusability of research data. They are a set of guiding principles intended to promote better data management and stewardship, enabling researchers to more easily discover, access, integrate, and reuse data. These principles are particularly relevant to archaeology, a field that generates diverse and complex data sets, often collected over long periods and across multiple projects. The first principle, Findable, emphasizes the importance of making data easily discoverable by both humans and machines. This involves assigning persistent identifiers, providing rich metadata, and registering or indexing data in searchable resources. Assigning unique and persistent identifiers, for example DOIS, to datasets, publications, and other research outputs ensures that they can be reliably located over time, even if their location changes. In archaeology, this could apply to excavation reports, artifact catalogs, or digital models. Describing data with rich metadata is crucial for discovery. Metadata should include information about the data's content, provenance, creation date, spatial and temporal coverage, and any relevant contextual information. Archaeological metadata standards, such as those developed by the Digital Archaeological record, can guide the creation of comprehensive metadata records. Finally, registering or indexing data in searchable repositories or catalogs makes it easier for researchers to find relevant data sets. Archaeological data repositories such as Open Context, Ariadne, and TDAR provide platforms for sharing and discovering archaeological data. The accessible principle focuses on ensuring that data can be accessed by those who need it, while respecting any necessary access controls or restrictions. Data should be retrievable through standardized protocols such as HTTP with clear and well-documented access procedures. This allows researchers to programmatically access data, facilitating large-scale data analysis and integration. Access to data may need to be controlled for various reasons, such as privacy concerns or intellectual property rights. Implementing authentication and authorization mechanisms ensures that only authorized users can access sensitive data. Finally, even if the data itself is not publicly accessible, the metadata describing the data should be openly available. This allows researchers to assess the relevance of the data and request access if needed. The interoperable principle addresses the need for data to be easily integrated and combined with other datasets. This requires using standardized data formats, controlled vocabularies, and ontologies. Using standardized data formats, such as CSV, GeoJSON, or RDF, makes it easier to exchange and integrate data across different systems and platforms. In archaeology, using standard formats for recording artifact data, stratigraphic information, or spatial data promotes interoperability. Employing controlled vocabularies and ontologies ensures that data is described using consistent and unambiguous terms. This facilitates data integration and allows for more sophisticated data analysis. Archaeological thesauri, such as the Getty Art and Architecture Thesaurus, can be used to standardize terminology. Finally, defining clear relationships between data elements is essential for interoperability. This involves specifying how different data elements are related to each other, such as the relationship between an artifact and its context. The reusable principle emphasizes the importance of providing sufficient information to enable others to understand and reuse data effectively. This includes providing clear licenses, detailed provenance information, and information about data quality. Applying clear and unambiguous licenses, such as Creative Commons licenses, specifies the terms under which data can be reused. This helps to avoid ambiguity and ensures that data users understand their rights and responsibilities. Documenting the provenance of data, including its origin, processing steps, and any modifications, is crucial for assessing its reliability and suitability for reuse. This allows researchers to understand how the data was created and to evaluate its quality. Providing information about data quality, such as accuracy, completeness, and consistency, helps data users to assess the suitability of the data for their purposes. This may involve documenting data collection methods, error rates, and any known limitations. Finally, here, adhering to community-specific standards and best practices for data documentation and metadata ensures that data is reusable within the relevant research community. Implementing the FAIR data principles in archaeology requires a concerted effort from researchers, data managers, and institutions. This involves developing and adopting appropriate standards, tools, and workflows. First, creating data management plans at the beginning of a research project can help to ensure that FAIR principles are considered from the outset. Second, providing training and education on these principles and best practices is essential for promoting their adoption within the archaeological community. Third, developing and maintaining robust data infrastructure, including repositories, catalogs, and tools, is crucial for supporting FAIR data practices. And fourth, collaboration and coordination among researchers, data managers, and institutions are essential for developing and implementing FAIR data standards and best practices. The FAIR data principles provide a valuable framework for improving data management and stewardship in archaeology. By embracing these principles, archaeologists can enhance the rigor, transparency, and impact of their research, fostering a more collaborative and data-driven discipline. Implementing FAIR data practices requires a concerted effort from researchers, data managers, and institutions, but the benefits are well worth the investment. As the volume and complexity of archaeological data continue to grow, the adoption of FAIR principles will become increasingly essential for ensuring the long-term sustainability and impact of archaeological research. The archaeological project iDAI.world, developed by the German Archaeological Institute, exemplifies the implementation of the FAIR principles and serves as a central infrastructure for the sustainable management of archaeological research data. Its use of standardized metadata, persistent identifiers, and structured databases ensures that resources are findable. Accessibility is achieved through open access web portals and APIs. By adhering to established data standards such as SciDoc CRM and controlled vocabularies, it ensures high interoperability across systems and disciplines. Furthermore, the platform publishes data in well-documented machine-readable formats with clear licensing and provenance information, making them reusable for research, education, and public engagement. Despite all the advantages of the methods and tools used in digital archaeology, we should also be aware of the risks. Let's briefly discuss the most important points with which we should take a critical look at digital archaeology. We have already listed many positive points that make work much easier for us and others. One of the most persistent critiques of digital archaeology centers around the potential for technological determinism. This perspective suggests that technology is the primary driver of social and cultural change, effectively shaping archaeological research questions, methodologies, and interpretations. Critics argue that an uncritical embrace of digital tools can lead to a situation where the technology dictates the research rather than the research questions guiding the choice and application of technology. Another significant concern is the potential loss of tacit and manual skills within the archaeological profession. As digital tools become increasingly prevalent, there is a risk that traditional archaeological skills, such as excavation techniques, artifact identification, and manual drafting, will be devalued or even forgotten. Digital archaeology is inherently reliant on software ecosystems, which can present a number of challenges. These ecosystems are often proprietary, meaning that the software is owned and controlled by a commercial entity. This can create a dependence on specific vendors and platforms, which can be problematic in several ways. The increasing commercialization of research outputs is another area of concern within digital archaeology. As digital tools become more sophisticated and the demand for archaeological data grows, there is a risk that research outputs will be treated as commodities rather than as public goods. That was the introduction. Welcome to the world of digital archaeology. After listening carefully to this lecture, answering the following comprehension question should help you to summarize the most important statements again on your own.